let's move on to our next topic, measurement of angle. Now, in trigonometry, angles are basically measured in the anti-clockwise direction. And any angle which is measured in the anti-clockwise direction is assigned positive. Example, if let's say you took this angle 60 degrees, you measure this angle in the anti-clockwise direction, that's on the coordinate system, then this 60 degrees will be assigned positive. Just that it will be mathematically tautology when you add the positive. So generally we just write 60 degrees. So whenever you see any angle, either 30 degrees, 40 degrees, 50 degrees and so on, it means all these angles are measured in the anti-clockwise direction. And that's by the rule under trigonometry. However, angles could also be measured in the clockwise direction. And any angle which is measured in the clockwise direction is assigned negative. Example, let's say we have this same angle 60 degrees being measured in the clockwise direction. So it will be like this. Of course, always starting from the positive x-axis. It will be negative 60 degrees. Are you okay? Thank you. Then we move on to our next. Also, in trigonometry, angles are either measured in degrees or radians. I take it again. Angles are either measured in degrees or radians. Then in degrees, as you already know, when you take an amount of rotation, the measure of that amount is what we normally call the degrees. Do you get it? Then by the time you make one complete rotation, we say you have described what we call a revolution. And as you can see, one revolution describes a circle. One revolution describes a circle, as I have indicated on the diagram. Then what is the sum of the interior angles of a circle? Is 360 degrees. And for that matter, one revolution measure of an angle, one revolution measure of an angle is always 360 degrees. Then one may also ask, what is radian measure then? Now let's say, as I said earlier, we said once you take a certain amount of rotation, you are describing an angle. And by the time you make one complete revolution, you have described 360 degrees. Now there could also be a situation whereby the moment you start describing your revolution, that's the circle, you see that you'll be describing a circle along the circumference. And that as you are describing this circle, you are equally describing an arc. And this arc, it will get to a time, the arc that you describe, that is when you know what an arc is. An arc is a part of a circumference of a circle. So let's say this arc is S. Then it will get to a time whereby the length of this arc you've described through the rotation will be equal to the radius of the circle of which or in which the revolution is taking place. And when it happens like that, we say you have what? Measured one gradient. You have measured one gradient. So if it happens that you describe an arc or you take a turn which you end up describing an arc which is twice the radius of the circle, then you might have measured an angle of 2 radians. And don't forget, radian measure is always shortened RAD. Then moving on, don't forget I told you earlier that by the time you make a complete revolution, that's one revolution, you might have measured an angle of 360 degrees. In the same way, by the time you might have completed one revolution, you might have equally measured an angle of 2 pi radian. 2 pi radian. You know, the pi is an irrational number, or it's a constant. So if you want to valuize this whole thing, then you can easily substitute in the value of pi, which is 3.142 approximately. Then you multiply, and the value what you will get will be the radian, 1 radian measure. Sorry, it will be 1 revolution measure of what? An angle. Now, what does this mean? All this hula baloo, what does this mean? What it means is that at any point of turn or any amount of rotation that you make, you measure an equal angle in degrees as in radians. So what it means is that since one revolution is equal to 360 degrees, and we are being told that the same one revolution is equal to 2 pi radian, what it means is that 360 degrees is equal to 2 pi radian. Then with this, what this goes on to tell us is that when we take any measure of degree through rotation, we measure an equal amount of angle in radians. So what it means is that an angle in degrees is always equal to an equal measure of 10 in radians. So it's always also equal to an angle in radians. An equal measure of angle in radians. So by ratio and comparison, or by ratio and proportion, we can say that in degrees divided by 360 degrees is always equal to an equal amount of angle in radians divided by 2 pi radians. And with this, we can always find an angle, or we can convert an angle in degrees to radians, and vice versa, using this formula. Are you okay? Now let's move on. So let's try some examples with this. Let's try working some examples with this. I've already given you some examples in the slides provided, or in the lecture notes I gave to you. But let's use my own example and see. Let's say you are asked to convert 60 degrees to radians. Now, first thing you have to do is we use the formula as I gave you. That's angle in degrees, the ratio of angles in degrees to 360 degrees being equal to the ratio of an angle in radians to 2 pi radian. So with this, since we are converting 60 degrees to, it means that 60 degrees is already given. So for that matter, we let a variable represent our radian measure of that angle. So we say let x be equal to the radian measure of 60 degrees. So by substitution we will get 60 degrees divided by 360 degrees being equal to x divided by 2 pi radians. Then making x the subject, we will end up getting x being equal to 60 degrees divided by 360 degrees times 2 pi radian. So at the end of the day, we will end up getting 1/3 pi radian. Now let's try another example. Let's say you are being asked to convert 2/3 pi radian to degrees. Now using the same formula as earlier, we say let y be equal to degree measure of 2 over 3 pi radian. So by substitution, you end up getting y divided by 360 degrees being equal to 2 over 3 pi radian divided by 2 pi radian. Then making y the subject, we will end up getting y being equal to, that by simple analogy. So we will end up getting 1 over 3 times 360 degrees. And this we will end up getting 120 degrees. Now, looking at the lecture notes given to you earlier and also the slide, you can see that some examples were worked. So following that, I would like you to go and try these questions. They are 4 in number, and present them for marking in our next meeting. Thank you.